No, you just read it.
Let the probability distribution function of the random variable xy. Probability distribution function let us slice the bread probability density function. And if you take the whole log of the bread, then that becomes the probability distribution function. It should be a joint probability density function of u and v. Okay. So g of u be equal to some function.
So what is given to you is f of xy is given with two values.
Okay.
When x and y is greater than 0, that means in the first quadrant. So you have to draw the picture. Draw a xy coordinate and draw it as xy greater than 0. That means you are considering the function only in the first quadrant. When it is in the first quadrant, f of xy is equal to some function. You don't know how to draw it. It's very hard to draw.
Okay.
That is because alpha square e power minus something 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 is given. So it's very difficult to draw that, right? It's not that simple. E power minus
x plus y the whole divided by alpha.
Yeah, it's hard, very difficult to draw that.
Yeah, it's very difficult.
But it is given alpha is greater than 0. Some parameter is given. Now, what you want to draw this.
Yeah.
So to draw that, what are you doing? You are changing the coordinate system from that to some other coordinate system, so that you can visualize. Okay. So that is what is actually mapping function means. You are in a domain which you are not able to visualize. You change the domain into another range where you can visualize it.
Okay.
That is the whole purpose of mathematical transformations. So that I am able to visualize. See, I am not able to solve a problem in my normal domain. What do? I transfer that into a frequency domain. So that my frequency can be drawn very carefully, easily. Because number of occurrences, too many parameters, how do I measure it? I cannot see so many numbers are repeated 100 times, 1000 times, 2000 times. So what am I doing? I am changing that domain into a frequency domain. So I am only considering not the physical value, but how many times it is repeated, I will solve it there first. So here also what are you doing? You are substituting. What is the substitution?
Substitution, we have to find a distribution of, what is the distribution of half of x minus y, 1 by 2 of x.
So you are substituting a new parameter. See, in your problem there is no u, there is no v. There is only x, y, alpha, right?
Right.
So you are substituting. Substituting itself means you are changing the problem from one platform to another platform. So that your equations become simple. So what is that substitution? Let us substitute and see whether it will become simple or not.
Okay.
So what is that substitution?
Here we should substitute some dummy variable like u.
Yeah, you read that. So what you should do is you should transfer this into a new domain. And what is the substitution you are giving? Read it. Don't just read what is that formula.
Substitution. U transformation is u equal to 1 by 2 of x minus y.
Yeah, u is equal to half x minus y and v is equal to y.
Okay, but my question is, why can't we take v is equal to some other value like
that is
equal to x plus y? That is what
I am saying. For this domain, To simplify it, you are identifying some methodology. For that, whether to take this to this place or this place or this place. Suppose you say x plus y is equal to some u is equal to some number, v is equal to some other different formula will take you to either this place or this place. The range keeps changing based on the function which you are using. So somebody has identified this is the easiest method for which you can solve this problem. Okay, so how do you know which function is useful? That is what, see, I could have given you a solution, not a problem. But I want to tell you what is physically happening so that people identified, oh, there is a problem like this. Now, when you solve it and come back, you will know why you have gone here. Okay, so ask this question yourself after some time, after solving this problem. Now, temporarily believe that somebody has identified.
Okay, fine.
What is that problem? The problem is to solve this, you have to substitute. He is not telling x equal to 2u plus v, you have to substitute. He is telling u is equal to this, you have to substitute. But actually, that is not what I am doing. I am visualizing what is my x. In this formula, when I look at it, I can identify x plus y by alpha in a e power. If I draw that picture with all the formula, what do I get? No, I'll get a trajectory like this. And that is a exponential function. But I am not able to solve this exponential function because its curve is too much. The variation is too large. The angle is keep on varying. Because it's a curve, it's keep on varying. So what am I doing? I am substituting that as a line vector. Line by line, line by line, line by line. I am segmenting it into bits and pieces. And what is that segment line? X is equal to 2u plus v is an equation of a line. Where u and v is another parameter. So from xy plane, I am taking that to an uv plane. So what I have done, this equation which is representing a curve, I am changing it to a UV plane where it will become bits and pieces of lines. So I have a big curve, exponential of some function is always a curve. Right? It's like a parabola. You take a log function, it becomes a parabola. So you can imagine, I have to imagine a parabola exponential function which is varying too much with a small change in the parameter. It will vary too much, it will jump faster. So I am not able to visualize it. So what am I doing? From that plane, I am taking to an xy plane, to a uv plane. Xy is too drastic changing. I am taking it into a uv plane. And in the UV plane, it is equal to a line. See how simple I made it, you see. U is equal to half of x minus y. I changed it into, so what will become x? X will become 2u plus v. Did I not change it into a simple equation now? Now substitute. Now what is the Jacobian transformation? You see the transformation. This is a transformation. So what is the transformation? I am not looking at function by function now. I am looking at the partial derivative with respect to x and y, partial derivative with x and y and u and v. That means I am looking at the slope. So the parabola had a big slope. I have changed that parabola slope into a line slope which is handleable to me. That is why you have got the Jacobian transformation matrix is given there.
Yes.
Now you look at the problem as changing from a domain to a range or one plane to another plane, where I cannot solve, I cannot visualize the slope, and here I am able to visualize the slope. The relation between those two transformation is what is given as Jacobian transformation. Okay. So now what is the problem now? The joint PDF of random variables u and v is given as, now look at the random variable, how is it behaving? Now xy is out. I have got only uv. What is that now? The formula is rewritten as, yeah.
2x is equal to 2u plus v and y is equal to v.
That is changed now. Now guv it
okay.
has become, yeah.
Okay. Okay. Then the probability distribution function of u and v is given as the product of the Jacobian and the PDF of xy in terms of u and v. Then in order to obtain the PDF of u, integrating with the limits of v.
So in the substituted function, you apply these conditions, then what you will get is that new formula, minus infinity to u to infinity to, it can vary anywhere.
Okay.
You can vary anywhere. Okay.
Because u is equal to 1/2 of x minus y. It
Yeah.
varies from 0 to infinity.
Yeah. So there can be
zero.
Yeah. Therefore, what will happen? Your new boundary function is changed now. The boundary also changes. When the function changes from one range to another range, the boundary also changes now. Okay.
Okay.
Now what are you doing? Now you are getting the integral function, because that function is integrable now. It has become, okay, the solution is known to us. That is why it is taking integral of, now because you have taken a differential, the Jacobian function has become a differential. So to get back to the formula, what you should do? Integrate it. Solve in this. So how did you get from here to here? By differentiating. Partial differential equation you have applied. Okay, so you take this function exponential of e power x plus y, what is that, minus 2 into all that you take. What you will get is that partial differential equation when you solve it. That is what you will get it as 2 by alpha square exponential of minus 2 by alpha into u plus v and all that you will get. So this function you have taken here by differentiation. The integration will get you back to the solution. That's what you have done. And the boundary condition also will change.
Yeah, but I have doubt regarding how the boundary conditions of v changes.
You just apply.
U is absolutely fine for.
No. What you do is you take this x and y greater than 0 in the first quadrant. What will happen to the slope? The slope can vary from minus infinity to infinity. U, it's like a equation of a line in which 2u plus v. The slope can be minus infinity to infinity sort of a thing. It can vary from 0 to 360. Anywhere it can go. So your condition changes. Right? Yeah. So that is what is given there. Minus infinity to u to infinity. What you should do is you apply these formulas into these conditions. Take that formula, put x is equal to y, x equal to 0, y is equal to 0, x equal to y, and few places you identify how the value is varying. You will get minus infinity and infinity also for u. What is u? U is equal to half of xy. Now it is like uh, the variable which varies in one range from 0, in the other range when you go, it could become too far from your normal 0 can go to infinity. This is saying the boundary is from this to this. Only x-axis with a very specific value it was given. Now in the whole range, it can go anywhere, no, without conditions. Okay, so what do you do now? You distribute from 0 to infinity, minus infinity to some value, so that the integration becomes easier. You can apply it easily. For in the first quadrant when it is going, what will become now? The xy plane has become uv plane. The u greater than 0. It will have a condition. U greater than 0, u equal to 0. All that will have a new condition to be applied in the range. That condition also will change when it depends on the equation. So how do you get that equation? Substitute this x equal to 2u plus v and y is equal to v into these conditions, these equations. How do that boundary condition changes? With respect to, suppose you take the extreme value x equal to 0, y equal to 0.
But let me ask you one thing. Here y is equal to v, right? So
yeah, y is equal to v. V.
So if I think in this logic, y is greater than 0. So v is greater than 0, right?
Yeah.
Then, but here the limit changes from v greater than minus 2u.
See.
That's what disturbs me.
See, what is that when you substitute what you will get and integrate, differentiate what you will get?
When we integrate, we get this function of u as piecewise functions from this interval to this interval, from the next interval to next
now you are not working in the domain, you are working in the range. And what is in the range? It's a differential function. So your limit also gets differential functions. See, you are changing the parameter to u and v. That means your differential function is what you are looking at. G of uv in a changed situation is not x and y. It is the differential function of x and y. Your parameter which was x and y, which was only in the first quadrant, which says x and y greater than 0, now u becomes minus infinity to infinity.
Okay, minus infinity. Other pakkana, adenki manasilayi. U changes from. But my question is, y is equal to v.
For all the u between minus infinity to infinity, what is the value of u? What is the value of v? Where it can vary. In the first quadrant, what is the value is given. In the other quadrants, it is 0. Your function was defined like that. Okay, original function. Now what are you doing? In the transformed domain, same condition is applied. Everywhere else it is 0. That means the second, third, fourth quadrant, the function is not applicable. You are not looking at it. You are only looking at the first quadrant. See, what can happen when you transform from one to another one? The variable can go in any quadrant. But the condition is given, it is not applicable in third quadrant. You only look at what is happening in the first quadrant when u and v are positive. That's all what you have to see. So same way, when the transformed function also, what are you doing? You are considering everywhere else it is 0. Only when the u is less than 0, it has to be taken here. V is greater than 0, it has to be taken here. Some conditions are applied so that you get it into whatever domain you want. How do you derive that condition? You re-substitute this into xy domain and see whether when the function is going away from this, whether it is going to be in the third quadrant, first quadrant, second quadrant, where is it going? So because the problem is defined only in the first quadrant, in the domain also, when you substitute those values, when you get it back, you should not go in the other quadrants, only it should come in the first quadrant.
But V greater than minus 2u means the fourth quadrant, right?
Yeah, so it is not applicable. So it says you are splitting it. Earlier it was very simple, one condition only, x and y greater than 0.
But even in the
2u plus v. So x is equal to 0 will become v is equal to minus 2u. Very simple. Your function is x is equal to
okay.
2u
V
plus v.
greater than minus 2u.
So if x is equal to 0, v is equal to 2u. So what are you doing actually? You are transforming the function to, see here, I have drawn. I want you to draw this actually. So what I have done is, I have discarded this area. In this uv function, I don't want this area to be taken. Now I told you, when x is equal to 0, how do I change the condition to u and v? You substitute x is equal to 2u plus v. So x is equal to 0 means what? V is equal to minus 2u. So what am I doing in the x and y axis? Instead of x is equal to 0, I am transferring that to up to 2u. Between this, I should not apply the limit, it should go above that. So I am changing the condition to a different coordinate system, it is somewhere else. And then,
so doctor, you're saying that except the first quadrant, everything is possible, right? Like that.
That is what is given in the domain. So when I take it to range, my boundary condition also has to be seen. In that boundary condition, just substitute x is equal to 0, y is equal to 0 and see how this transformation will take me to the next quadrant. So when I put x is equal to 0, y is equal to 0, I will reach up to 2u, 2v, this value. So my formula will be applicable only here. It cannot be in the whole entire first quadrant of uv. I have to shift it by 2u above and then take it from there. That is why v is equal to some value is given. So my limit also will change. Accordingly, my limit will change. Now your new limit will be not first quadrant alone. First and second quadrant will happen because minus infinity to plus infinity. But it will get shifted from that u is equal to 0 to a u is equal to 2v function. Little higher or maybe little lower. It depends on what function you are looking at. So here what you have done, minus 2u. So it can go from this minus 2u. I have marked it already. Yeah. I can put it into minus 2u. So you put a uv axis, u can be x axis, v can be y axis, and put minus 2u. From here, I have to limit to this function. Earlier x equal to 0, x positive was what is taken. Now x positive will become the v equal to 0. It will become minus 2u will become the origin. It is not at u equal to 0, v equal to 0 now. I am shifting this to minus 2u v. So I'm shifting my origin from xy. X equal to 0, y is equal to 0 is the origin in this plane. But in the other plane, x equal to 0, y is equal to 0, in UV plane, what will happen? You substitute u is equal to v is equal to minus 2u. So the my 0, 0 here will become 0 to u. Happens to most of the teachers who are either mathematics or the other day also when I had an interview with somebody who was an engineering college principal, he was telling mathematics is too tough in engineering college. That is because you are not visualizing. It's not your fault. For me, when you are talking about this, I am looking at an application which I am using in my image processing, signal processing. We every day do this. I cannot solve a problem in radar frequency domain. I cannot solve because radar gives me frequency. So what do? I change that into my normal domain, create a picture out of it. Actually, frequency will not give you a picture, but I create a picture out of the frequency domain and then solve this problem, take it back. So now what am I doing? My domain also keep changing. I can either differentiate, I can integrate, so that I will have to take a function back to integrate it. If I am taking exponential, I should do a logarithm. If I am taking logarithm, I should do an exponential. So what is to be applied depends on what function I am getting. Got it? So visualizing it is very, very essential so that it becomes easy for me. Got it? So when I get a function like I have got a curve. No, curve cannot be solved because getting slope at each point becomes an integration. You can see actually your Riemann-Stieltjes integral and all that. I don't know whether you heard this. I wanted to integrate a function. So what do? I cut it into small pieces so that each becomes a polygon for me. I cannot solve a curve and integrate in computers. Is it possible? No, I cannot put functions inside that computer. So what do? I transfer that integral function into small bits and pieces so that each becomes a pyramid. Each becomes a rectangle. And the area for the rectangle formula is known to me. So when I have to integrate anything with a curve, what do? I convert that into small bits and pieces where I can convert. Now you must understand when I am integrating, when I am talking about integration, I have a curve like this which I cannot integrate. So what do? I take the projection to my x-axis into small bits and pieces. So each bit becomes a rectangle for me. And I can see the area for this rectangle, add all of them together.
So this is the normal integration, right?
Yeah. So now what am I doing? This function has become so much slopey, which I am not able to understand how do I fit a curve. Now what am I doing? To fit the curve, I am transferring into a different plane where the curve itself becomes small bits and pieces of lines. Now integrate it there and get it back. That's it. Finished. This is everyday job in image processing. This is everyday job in doing radar signal. How do I integrate? Then only I can talk about the how the function behaves, how the gray value behaves. So this is what I visualize every day. It is not because I learned maths and statistics I am able to do this. I have worked in application of all these functions for 20 years. So everything what we learn in differential equations, the distribution functions, see for me, it's a distribution function. Light is distributed and that is reflected and I am getting an image. So image is a random variable for me.
Definitely.
Which has got a beautiful, how do we identify whether there is a spotlight, the distribution becomes a normal distribution. If you take the center of that line, the top becomes the normal distribution. The top will become the average or the median,
Like the
mode,
bell.
everything becomes same and it equally distributed. Oh, that means you are looking the light from top. Suppose you are looking from the side, it becomes skew. Because some side, understood?
Skewness
No,
is there.
see, when you say skewness, kurtosis, normal distribution, it's like you get a bell picture, beautiful. Oh, you are from the top. So you understood. So when you look from the top, it becomes like straight. But if the same bell picture, if I look from the side, it becomes skew. So what am I doing? My median, mode, the frequency, everything keeps shifted from one to another one. So that if I know the difference between my mean and median and mode, oh, I know this is how the distribution function is. Which theoretically you must have learned, but you have never visualized. For me, it's a picture. From these parameters, I have to recreate the picture.
I have never visualized in the context that you told just now.
That's what I'm saying. See, for me,
maybe graphically we have seen many graphs and all that.
No, for me, mathematics and statistics is what I can see. That's a beauty. The other day only in my interview and today which I published in my YouTube, I mentioned that most of the maths teachers, and I'm not blaming teachers, I'm only saying they were never seen the application part of what they are teaching in the classrooms.
Absolutely.
So when they are not able to visualize it, how do you explain? It's very, very difficult.
That's why I asked you this question to you.
See, now my x-axis, y-axis is in a domain. When I shift it somewhere else, automatically x also will get shifted, y also will get shifted. Correct? And where do y go? Where do x go? Now what we have seen is, it was only in first quadrant. Now what has happened to this function? It has gone from minus infinity to infinity, but it goes the 2u. It got shifted in the first quadrant and second quadrant in a different domain. So now I can integrate that. Because when I take a parabola, assume that I am taking a curve. The curve can have a slope which is negative or positive. But still it is in the first quadrant only. In the same curve which is in the first quadrant can go up and down. It can go deep down, and valleys and mountains can be there. But when I am taking the slope, automatically the slope has become negative. And in some places, my slope can be minus infinity. Undefined slope, So it goes exactly if it is 0 like this, my slope is 0 when it is parallel. When it is vertical, it is minus infinity or plus infinity. Got it? So what am I doing? The slope function which I am defining from xy axis to uv axis, I have to move from minus infinity to infinity. This is the function. So when I see the function, I am not even looked at it when you said, I am able to see it in front of me.
I know that.
So why should I write? Why should I think about it? I don't even have to think about it. To explain to you, I don't have to refer, I don't have to read, I don't have to look at it, because I am seeing it. It's like you are asking.
But I have never learned this problem like this. This is something I think I have learned during my post-graduation.
No, I have also learned in the classroom with one of the greatest professors of statistics. Krishnamurthy sir taught me all this. So this I have learned, theoretically I have learned. But when I look at it today from that point of view, probably my professor also would have realized it, he must have looked at it, he must have seen this in front of him. But he was not capable, or we were not capable to visualize it in that extent.
Maybe it could be due to the fact that in order to make somebody visualize a thing, even in this equation also, you actually tried a lot to Make me understand this.
That is why I don't want to give a solution by typing this is the answer. I want it to tell you like this, so that when a next problem comes, you can visualize yourself. Got it?
Right.
So
Right.
basically we must understand why are we doing. You can see a generating function. Fourier transformation. You have got a generation function. Like, see, sometimes you will say, this is what you should substitute to get the solution. That is because, you have to transfer this from this domain to this range. Only then I can solve it. So what do I do? Here it is very clear. I have to create a line by line, bits and pieces. That is how tangents are drawn. Understood? So immediately x is equal to 2u plus v. Nobody has to tell me what is the generation function, what is the immediate thing what I do is that only. Exponential function, logarithm function with something which is coming, which is a beautiful curve to look at it. I can't solve it. Otherwise, I have to transfer it into sine and cos. So therefore, generating functions are either linear, u is equal to v plus v or something like that, or sin x or cos x. These are the things which generally we substitute, so that I get a wave which is close to wave. But here, this function is not close to wave. That is why lines are given. So you will always see transformations will be either sin x, cos x, or a linear function, or x is equal to t square, something like that, so that it becomes a circle.
Okay. Doctor, one more question. When we began this session, I asked you why we can't take v is equal to 1 by 2 of x plus y. Is it because of that it becomes more difficult to solve?
No, see, whether you are taking uv as xy or xy into uv, it's one and the same.
No, not that. U is equal to 1 by 2 of x minus v. We have to find out that.
Yeah.
So in order to solve it, we need one more equation, right? One more equation for transformation, right? So here we took it as v is equal to y.
I re-looked at my mathematics classes.
Most teachers tell that when they were actually learning that subject, they just learned it, they didn't understand that. But when you are in the profession, you would feel like,
I was blessed to have Krishnamurthy sir as one of the teacher, and he was a really genius man. He had a lot of experience. He was going abroad and teaching those days. He used to go to Russia to teach statistics. He is there in CMS college now.
I know.
What a beautiful class now. But okay, probably none of us were brilliant enough to understand what he speaks, but that has given some visualization. And for him also, see, I was not able to believe how he is coming and taking classes without preparation. Now I know why he is able to do that.
Okay, then how he used to take class?
He will be sitting and doing some research in his room. We have to go and tell him, sir, come, this is now your class. Then he will come. Where did we stop yesterday? Not and go. Okay. He will open somebody's book and then see, this is the problem. Now close it. Now he will go and write whatever he wants there. Not exactly. See, it's not like other mathematics MSc classes where he will take a problem and solve it and all that. He will only tell the theorems. He will tell you the theorems. He will tell you the proofs. Just like that. And many a times what happens is he will solve somewhere and then he will reach somewhere. He will say, everything is wrong. I went in a wrong way. Rub it off. He will rub everything.
I think exactly that is the way how to solve a problem.
Yeah, that is why. So then we know where he went wrong, why he went wrong. All that can be done. We had such teachers. We had such teachers
Because I really,
who never looked at the
I
books
really,
and then read it and all that, never did it. All our teachers were like that, brilliant, except a few. Rest of the teachers were all bright and great teachers. So topology is one
because
which I know. Um, just like that, I know topology. I can teach topology without any reference. Maybe operation research, probability and statistics. All these classes were like that. Dynamics. Complex analysis. All that was wonderful. And we had a beautiful paper. That is what I think most essential for everybody to learn. Algebraic geometry. But the teacher was horrible. He couldn't do anything, any justice to what he was doing. But because the teacher was bad, I did a lot of my own learning. And that was so interesting. Algebraic geometry. That means every algebraic equation you have to visualize as geometry. Every geometry has to be seen as algebra. That was a paper introduced during our semester, which was never there earlier. And I was not a very good student, but I scored the best. I mean, not very good means I was not getting always first in the classes. But algebraic geometry, throughout all exams, I was the first. I think after that they took out that paper also. Only 1 year for our semester, there was one Chakravarti who came from USA who was interested to teach that, and then we had few people opted for that, and then we learned. But that was a great blessing.
oh, that was an elective course.
That's an elective course, and then not many were there. But that was a beautiful paper, algebraic geometry.
I think even in your case also, if you don't know something, you'll say like, എനിക്കറിയില്ല എന്ന് തന്നെ പറയും. പക്ഷെ some teachers won't say that.
Yeah. See, there is no point. I know if I can push and then open the door, I will only push at the door.
But I think the real teaching should be like that. I mean, if you're writing something and halfway through you come to know that it's not the right way, or you തെറ്റിപ്പോയി, I think that's the way how the classroom should function.
Yeah, we had good seminars. We had a cross-department seminar. So physics department people will come and they will solve the problems. So sometime what happened was, I remember when somebody started with a problem, it was first order ordinary differential equation. He was keep on solving it, but it became a partial differential equation later. Then I said, you started with a simple problem, you are complicating. Hey, we can't accept it, I said. You have to have that courage to tell no.
And most people don't like that too.
No, how does it matter? It doesn't matter. No, we are only talking subjects related to what we are learning. But that means you are looking at it, where you started, where are you going, you are following what is being written on the board. If that is not there, anything happens there, you don't care, right? That is what in most of the classrooms, that is what happens. But for us, it was not like that.
Okay. Even the analogy of that bread and the slice of the bread, get that idea in the right sense. Otherwise, if we are using some mathematical terms and all that, it becomes really horrible. But I also really enjoyed discussing this.
No, mathematics and statistics is a real life problem. It's like a language, right? So you must visualize it. It's like.
But I have never in my life visualized like this, especially these problems. I have used it in geometry and all that, like solving simple equations and all that. But I never even thought like ഇത് ഇങ്ങനെ ചെയ്യാൻ പറ്റുമെന്ന് പോലും ഞാൻ വിചാരിച്ചിട്ടില്ല. Because we have been seasoned like that.
No, the generating functions are beautiful things, the Fourier I taught Fourier transforms and such things to teachers in engineering colleges also. Electronics, electrical engineers, electronics engineers, computer science engineers, they all of them use the signal processing functions. So in which lot of generating functions will come. So all these generating functions are the root one, which actually that's also transformation. The Fourier is a transformation. So Fourier series, when you learn in engineering, it is Fourier series. Physics, it is Fourier series. But in mathematics, it is Fourier transform.
Okay.
It is one and the same.
But you told like transformation എന്ന് പറയുന്നത് ഇപ്പൊ ഒരിടത്ത് ബാധകമായിരിക്കുന്ന ഒരു കാര്യം വേറൊരിടത്ത് ബാധകമായിരിക്കില്ല, അല്ലെങ്കിൽ like how you behave in a house would be different when you behave in another house, right?
100%. See, assume that
it's
I am
as
not
simple as that, but
I am not able to solve something in the image is given. When the image is given, to describe the image is too big. If I take the picture of the room, it's very difficult for me to describe it. But if I take a frequency function of it, oh, I will only know there is a bright light there, there is a dark place there. So the distribution function is very beautiful, no? Wherever light is there, the frequency is high. Wherever zero value, dark is there, the frequency is high. The rest of the distribution function is very clear to me. So if I know how to describe it and segment them into different classes, and then
and I think in please continue.
yeah,
Sorry to
continue.
interrupt. And I think in case of distribution, I mean PDF and PMF is there, no?
Yeah.
So when it becomes discrete, it is like mass function. It's only concentrated at a point.
Yeah.
But in case of the continuous function, it's like a density.
Yeah, that is because it's like you have got either a histogram or a frequency curve. But histogram, the middle you take and then connect them, it becomes a curve. Approximate.
Yeah.
See, understood. Every year what happened you wanted to know. So year wise you have got block, the frequency into 1970 to 2022. So you are putting them into blocks. But you want to make it a curve, what do? You take the center and draw a curve. So it becomes continuous, right? That's it.
Thank you so much, doctor.
Okay.